Welcome back to Young Engineers of Today. I hope you're ready to continue with Arduino because that is what we are going to be doing. No, it wasn't a virus. It was. I'm thinking that there's some hardware component on my computer that is starting to fail, and I'm really hoping that's not the case. But um, it's possible. It's entirely possible. On top of that, I think I need to reinstall Windows. It's a mess. It's a mess. At any rate, it's working now. So let's go ahead and enjoy this moment while we can. We are going to do more with Arduino today. There is going to be a makeup sort of class, but because this is going to be a direct continuation of our last Wednesday class, which, if I remember correctly, we got the LED blinking. Um, I'm thinking that the makeup one on Thursday that I'm just going to upload to YouTube. It's not like you guys have to join it or anything. It's just going to be sort of an extracurricular thing. I'm going to go a little bit more into detail about the some of the terms that I talk about and stuff like that. Circuits.io. We're going to go back to that again today, and we're going to spend some time messing around with that stuff. But yeah, I'm thinking that's what my class on Thursday is going to be. I'm not entirely sure yet what all I'm going to go over. I'm probably just going to spend time rambling like I tend to do. So basically the same kind of thing that I always do, except I'm not going to have you guys making, smart comments in the comment box or anything like that. But we'll figure it out. We'll figure it out. Hopefully it'll be something that's a little bit off the beaten path, but sheds a lot more light on Arduinos and programming and computers and stuff like that in general, because that's sort of my wheelhouse. I'm no expert by any means, but I do enjoy it, and so hopefully some of the information I can talk about then will go shed some light on things. Anyway, so we built a circuit last Wednesday. We built a circuit and we programmed an Arduino, and it made the light up, and then it made the light no longer light up, and then it made the light light up, and then it made the light no longer light up, and you get the idea. We basically made an LED blink. Super thrilling stuff. Now, as if that weren't enough, we need to add more LEDs into the mix. So now we're going to do the same thing, except we're going to make many LEDs light up. But this is actually an excellent lesson, despite the fact that you just kind of look at it and you go like, really? Like we're going to do the same thing but with more than one LED? You would be correct, but there is some stuff on the coding end and some stuff on the electronics end that is actually excellent learning material. You may not believe me, but you should. Yes. Yes, you should. So let's go ahead and let's get started with this one. So we're going to be connecting 8 LEDs and controlling 8 LEDs. Believe it or not. Believe it or not. Again, we're going to go over what, hardware we're going to be using, and we're going to get set up on circuits.io. We're going to talk about, the program itself, and then we're going to talk about messing around with the program in order to create patterns with those 8 LEDs. So, hardware. You guys know what those are. I don't have to tell you. Like, they're LEDs. No surprise there. La la la, long. Actually. These are resistors limit, blah, blah, blah. We never actually went over this. But maybe you guys might know this. What are the / **, and double /*? Does anybody know? Has anybody worked with Arduinos before or similar programming languages? Java has the same syntax for this. No takers? Okay. Well, they're comments. Comments are very useful because they allow you to, in the case of this code right here, I could say like, I could put in the double forward slash and I could say this comment, no. Let's say LED pin keeps track of what pin the LED is hooked up to. Yeah. The comment is invisible to the compiler. It sees those double forward slashes and it goes, map, okay, never mind. All right. I'm not gonna pay attention to what's there. And that's it. That's what it's for. So it allows you to make helpful notes for yourself so that you can keep track of what you've written in the program. Pin mode sets the output, sets a pin to be either input or output. So, you know, like 6 months from now, if you pick up this code again, you're like, why does that? Oh, pin mode sets a pin to be either input or output. And since it says output here, we set it to be output. All right, I get it now. Okay. So that kind of thing. It's commenting is very useful. It's a godsend. It's necessary. It's sounding like I'm exaggerating, but I'm really not. Like, a program like this, you don't need commenting. Like, really and truly, you probably don't actually need commenting because it's simple enough that you can keep track of everything that's going on. An actual program, though, whew, that is going to be an entirely different story, especially because you're going to start getting to points where you're going to have to go like further and further down a rabbit hole trying to correct something that's weird with the way that the computer converts, like the operating system converts like strings from ASCII to Unicode and back or whatever. Just insert some random, you know, computer science dilemma here. And so you're going to write this whole function that fixes that, and maybe it calls like another function that you have to do something specific for. And it's beautiful and it's abstracted, and you could actually apply it to so many things, and you're so proud of it. And you write it, and then you go work on another project, and you come back to this 6 months later, and you go, I have no idea what any of this stuff does. Because the variable names, they're helpful, but not enough. And it's so abstracted you can't really tell what exactly is going on. Maybe you do some tricky thing like, you know, bit shifting or something like that, some weird hacky thing, which, you know, is generally discouraged from being, you're generally discouraged from doing, but, you know, let's be real here. Any programmer in the course of writing a program is going to do some sort of weird hacky thing in order to make it work. And you go, well, why is this here? And, you know, generally it's just going to be an unreadable mess, even though you wrote it. Now imagine how hard it's going to be to read somebody else's code. Yeah. So commenting the code is good to basically elucidate, to shed light, to illuminate what exactly is happening here. So in case you're reading it in the future, or if somebody else is reading it at some point in time, they can go, okay, so I understand why this is happening. Now I didn't even touch on these. Well, this is a set of comments, or a set of comments symbols. The double forward slash is easy, but there's one failing. It applies to one line only. Yeah, it makes open source programs readable to all. Yeah, pretty much. So I can be like, here is my comment some more. And that doesn't, I can't do that because this comment here is one line only. So I could do this, but then let's say we wanted to have like a big long explanation, and it starts getting old. Instead, what we can say is we can go /**. And now I can start typing, you know, lorem ipsum so dolor amet. I don't even remember what the rest of it is. It's something like that. Blah, 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 blah. I want to suck your blood, blah. Anyway, I'm losing my mind. And this is all still a comment. This is, in fact, still a comment until we add this. Not the arrow, but what the arrow is pointing to. In fact, it is an asterisk and then a forward slash. So exactly the reverse of this first one. So you can think of the forward slash sort of wrapping around everything, and then the asterisk is kind of like a, I don't know, you can think of them like bookends or something like that. But basically, everything inside of these two symbols is going to be a comment. So now you've got single line comments and multi-line comments. And that's what those are for. And that's just so this stuff is readable and decipherable. Multi-line comment. This example is only 3 lines, but could be as long as you'd like. Yeah, basically. The curly brackets are for denoting the beginning and end of a function. And you can think of them like a container that holds the function's code. Like, how many of you messed around with Python before? Show of hands. Really? Only one person? Okay. Well, how about Java? Or JavaScript? Okay. Same hand. So you know exactly what the curly brackets are for. Basically, all of the code contained within these curly brackets is considered a part of void loop. Anything not inside of the curly brackets is not considered a part of void loop because it's not inside of void loop's curly brackets. Anything inside of these curly brackets is considered a part of void setup. Anything not inside of these curly brackets is not considered a part of void setup. You have a mod that you made? Excellent. All right. Sounds good. But yes, okay, so yeah, that's basically what those things mean. We know how to define a variable. Let's get to the hardware business. So I'm going to go ahead and open up circuits.io. Beep. And I'm already logged in. I'm going to go ahead and create a new circuit. So I'm going to click on Create. And I'm going to click on Open Electronics Lab Hub. And then I'm going to click on New Electronics Lab. Bing, bang, boom. So now, once this is all done loading, we will be looking at a breadboard. Ta-da! So excellent. That's what we're looking at. So far, so good. Now, what do we need for this? Well, we're going to need more than just that. There we go. That's what we're doing. We're doing 8 LEDs. So you may have noticed something here. We're using different pins. We're using pins 2, 3, 4, 5, 6, 7, 8, and 9. So we're not starting at 1. We're not starting at 0. And that's because those are reserved pins. So we start at 2 and we work our way up. But in essence, we're not going to use... Oh, yeah, 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 yeah. So you have worked with Java before, since this is a Minecraft mod. Excellent. Nice. Did you do the summer camp? Sorry, that question was for Mateo. Did you do the Minecraft summer camp? Yeah, sure. Yeah, let me bring him up. Oh, you didn't. Okay, so you did it on your own? For everyone's reference. Um, Actually, why don't we go over that at the end of the class, just to make sure we get this done first. But I do like that. Sorry, I started getting, yeah, yeah, yeah. Um, but yeah, we'll definitely spend like the last like 10 minutes or so going over it. Um, all good. Yeah, I understand. All right, so yeah, we're looking at the breadboard, and this is what our circuit's going to look like. So let's go ahead and build it. Now we're going to have a common ground, but we're not actually going to have a common power because all of these different LEDs are going to be hooked up to separate pins on the Arduino. But we're going to need all this stuff, so let's go ahead and start bringing it all out. I'm going to rotate my breadboard just like before. So there we go, bam. There's our breadboard. I'll actually move it over here. Bring up the components tray. We'll bring out 8 resistors. Well, actually, I'll bring out 1 resistor, and I'll bring out 1 LED. The reason for that is because we can copy-paste them. Just Control-C and Control-V, and then you got to click to place the LED in order to complete the pasting. The reason I'm going to copy-paste with the resistor is because I'm going to go ahead and just make this resistor 330 ohms now, just like we did last class. Remember, you click on it, so it's selected. It's got the blue band around it, or the blue outline around it. And then go up here to the settings in the upper right-hand side that I'm circling with my cursor right now. Change the resistance to 330 and then just ohms. No kilo ohms, no milliohms, no micro ohms, no mega ohms, no giga ohms, no nano ohms, no pico ohms, just ohms. That way, when I select it and hit Control-C and then Control-V, I'm copying a 330 ohm resistor, and I don't have to change the value of every single resistor one at a time, because that would just be a big pain. So now we've got 8 resistors and 8 LEDs. Let's go ahead and just, if you hold down Shift, you can select everything with a box and move it all. I'm going to bring up the components menu one more time. And I'm going to bring in an Arduino, just like we did before. Bam. So here's our Arduino, our 8 LEDs, and our 8 330 ohm resistors. Now, if you wanted to, you could make these LEDs different colors if you were so inclined. Because why not? It doesn't really matter what color they are. There. R. Use R to turn it. There's also the rotate button. Um, in the upper left-hand corner. Copy, you can copy with Control C or Command C if you're on a Mac. You just have it selected, hit Control C, and then you hit Control V, and one will appear on your cursor, and it'll follow your cursor, and then you can just complete the pasting by clicking. And then you'll have an LED or a resistor or whatever you've copied. And you can just Control V, click, Control V, click, Control V, click, and so on. Delete. In fact, I could have simplified things even more and built one version of this and then copy pasted it down 8 more times, but whatever. So now that we've got all these, let's go ahead and set up our circuit, but we'll set up a super quick way. So let's rotate the Arduino. So I'm going to place an LED thusly. So we've got the anode and the cathode. I'm going to place a resistor thusly. So as you can see, the resistor is connected to the negative, the common ground. It's also connected to the cathode on the LED, and then the anode is on its own open rail. So just go ahead and do that with all of these. And yes, I am saying boop very quietly every time I place one of these down. I don't know why. Don't judge me. Now, why do you think I'm arranging the resistors like this? Well, simply put, I'm just doing it so that I don't have to run jumper cables from here over to the common ground for each of them. I can just go ground, connect, and now all of the resistors are connected to a common ground. In fact, let me just go ahead and clean this up a little bit. Because if you click and then right-click, you can draw curves in your wires. So now I've got, whoops, there we go. Now I've got the ground, the GND on the Arduino hooked up to the common ground, the minus wire, which all of the resistors are hooked up to. From here, now it is a matter of connecting the LEDs. So I'm going to go ahead and do that, and I'm going to give them colors that correspond to the LEDs they're hooked up to, just to make it a little bit easier to see. So as you can see, I hooked up the yellow LED at the bottom here to pin 2. So I'm going to start at pin 2 on the Arduino, just like we have in the diagram. Make this one a blue. That one will stay green. Just doing a little bit of wire cleanup so that they're closer together. Again, this is not, strictly speaking, a necessary thing to do the curves like I have, but it does make it easier to read the diagram. That's really my main concern right now, is making the diagram easy to read. And Arduino is going to be listed in the components list. You gotta pull up the components tray and then do a search for Arduino. So your final circuit might look something like this, in essence. I mean, it may not look exactly like how I laid it out, but the important thing is you got power going into the crooked leg on the LED, and the straight leg of the LED is hooked up to the resistor, which is hooked up to the ground. And then everything's hooked up to the common ground that needs to be grounded. And then you got the ground from the LED, or excuse me, the Arduino running into the common ground rail. I color-coded the wires because I'm a weirdo, but nah, you're not by any means required to do that. So I guess raise your hand once you've got a circuit looking like this. Cool. Got one hand up so far. 2 hand, 3 hand, 4 hand, 5 hand. No worries if you don't, no rush. I just want to know. Um, I don't want to leave anybody behind, so I'm going to hang out for a couple of minutes here until we get all the hands up, and then I'll move on to the next thing, because that's going to be the coding part. Hooray! Okay, perfect. Looking back up, I think we got everybody. All right, cool. So we got our circuit built, presumably built to spec. Let us focus on the coding. Okay. So does anybody remember what the two things we need in an Arduino program are? We're always going to need them. That's one of them, definitely. Void setup is definitely one of them. And void loop is the other one. Yep, exactly. So we're going to need those. Void setup. Oh my goodness. There we go. With our curly brackets, and void loop with our curly brackets. So that's the beginning of our program. That's the skeleton of it upon which everything else is going to be built. We're going to flesh out everything else on top of this so that we have a running Arduino program. But we need to have the void setup and the void loop. Always, 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 always. So do you remember how we set up the LED pin? What exactly we did? What was the first thing we did? Give you a hint, it was up here outside of either void setup or void loop. And the first letter of the first word started with I. Yeah, exactly. That's what we did in the past, right? And that worked out all right. So like we could say INT LED pin 1 equals 2, INT LED pin 2 equals 3, INT LED pin 3 equals 4, because, you know, the first LED pin is plugged into 2, and the second one is plugged into 3, and then 4, and then 5, and so on and so forth. We could do that, but let's not. Let's not do that. Let's do something way easier. we're actually going to use loops now. In fact, this would be a good way to go over arrays as well, but we're going to skip doing the array thing. Let's do loops. Loops. Now, in this hypothetical example, we have a loop. This is a for loop. The for loop iterates a certain number of times, and each time it runs, it's going to print a number to the console. This number is the number that the loop is currently on, but that's less important than what I'm looking for here, which is how many times will this loop run? How many numbers will be printed out? This is a little bit trickier because we haven't actually gone over for loops. Yeah, because we haven't done everything we need to yet. Eight? Okay, you're close. This particular loop is actually unrelated to, yeah, it's going to run 10 times. Now, this prints out the number that the loop is on. Does anybody know what numbers this is going to print out? This one's trickier, a trickier question, definitely. Well, you might say, oh, it's going to print out 1 through 10, but it actually doesn't. It prints out 0 through 9. In the end, it's still printing out 10 numbers, but it's not printing out 1 through 10. Now, what exactly is happening here? I haven't actually gone over that. Let me go ahead and go over that. So, a for loop is one of the more common types of loops you're going to see, generally. Because a for loop has 3 things that it needs in order to run. It has, let me go ahead and do this. This is not part of the code, so don't type this. For, denoting that it's a loop. It's going to have curly brackets denoting what is going to loop. This is the stuff that is looped. And then it's got 3 very important components inside of the parentheses. It's going to have a number and where it starts, then a semicolon, when the number should stop, and semicolon, and then math. And let me go ahead and maximize this so it's all in the same line. Done to the number. Apparently I can't type number because I don't want to type the B in number. Anyway, so for a number and where it starts, when the number should stop, and math done to the number. As long as, it would be numer, yeah, exactly. As long as this statement right here is true, then the loop continues. This statement is the, what's the word? Initial conditions, I suppose. This is the stop conditions, and then this is the iterator. And that's, those are like the 3 main components to a for loop. And all of these are important in order for a for loop to run properly. Now let's take a look at an example then. Specifically maybe the example that we have on the presentation. There we go. So for a number and where it starts. So let's say int I equals 0. So we've established a number, in this case a variable, and we established that this int starts at 0. So int I equals 0. Then when the number should stop. I is less than 10. So as long as I is less than 10, this loop will continue to run. Then the math done to the number. I plus plus, which is just shorthand for I equals I plus 1. It literally means the same as, so each time this loop is run, it will add 1 to I. It will increment I by 1. It happens commonly enough in programming that there is a shorthand for it. So those are the main components of a for loop. We have a variable and where it starts, the ending condition, so as long as this is true, the loop continues to run. As soon as this is no longer true, it will stop running. And then the math done to it, in this case, the iterator. So as you can see here, we start at 0. If we, in our example, printed out whatever number we're on, it's going to start at 0. It's going to print, 1, it's going to print 2, it's going to print 3, so on and so forth. It's going to get to 9, and 9 is less than 10, right? So it's going to print 9. Then it's going to iterate, and then it's going to get to 10. 10 is not less than 10. 10 is equal to 10. So it's going to be done. It's going to skip the rest of this and move on to whatever's after the for loop. And so the loop will have run 10 times at that point, because if we start counting at 0, that's an extra number, isn't it? If we started counting at 1, if we went 1 through 9, then we would have only printed 9 numbers. But since we started at 0, that's an extra number, so we printed 10 numbers. So we're going to be using the power of loops. I know I said that in a very dramatic way. We're going to be using the power of loops in order to initialize and go through our LED pins. So rather than doing all this business right here, I'm just going to go ahead and delete that. Goodbye. Go away. And we're going to include a for loop in our setup and our loop variable or functions. So for int I equals, now we're not going to start at 0. What do you think we're going to start at looking at our circuit? 2. Yeah, exactly. That's the cool thing about for loops, is they can start at any arbitrary number and they can end at any arbitrary number, presumably as long as they end. You kind of want them to end. If they don't end, usually that's a bad thing. In fact, pretty much always a bad thing. But anyway, so we're going to start at 2. So int I equals 2, and then a semicolon. And we're going to say as long as I is less than 10, because we want it to stop at 9. So as long as I is less than 10. And then I plus plus. Bam. So now we've set up our for loop. Now we need to do the actual stuff that's inside of the for loop. We're going to say pin mode I output. Whoa, what did I just do there? Well, here's the really handy thing about loops. There are a lot of really useful things about loops, but here's one that I think is particularly applicable to the situation. You know how we declared a variable here? And we called it I, which is a common name for a variable used in a loop. Well, for as long as this loop is running, this variable exists. I is here, and the computer knows about it. As soon as this loop is done, I is destroyed and lost forever to the ether until we start up another loop that uses I, or we declare another I, whatever. At this point, though, I just exists for the entire length of the loop and the number of times that it runs. Now, this is useful because we can actually use I like a regular variable. So we can use I here. Presumably what's happening here is the first time the loop runs, I is equal to 2, right? So the I in here gets replaced with 2. The next time it runs, it gets replaced with 3. The next time it runs, it gets replaced with 4, and then 5, and then 6, and you get the idea. Blah, 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 blah. It gets replaced with 9, and then we've run the loop for its last time. So what we've done here with 4 lines of code, which we can make 3, which we can make 2, which we can make 1, whatever. With 4 lines of code here, we've done what without loops would be accomplished in 8, pin mode, 2, output, pin mode, 3, output, pin mode, 4, output. This right here, this is doing the exact same thing that we're doing here, just a lot more work. Sometimes typing is fun, but not all the time, especially if you need to type out like this is the thing that makes a loop run 10,000 times. Just make it a loop. Don't type 10,000 lines of code. Make it a loop. I mean, we're all sane people here, right? So yeah, that's what we've done here, and that's actually a major component of programming in anything, is utilizing loops to their fullest effectiveness. So that's what we've done here. We've utilized the loop to its fullest effectiveness. Now we're going to introduce another loop here. I wonder what it's going to iterate to and from and to. So for, in this case, int I equals 2, I is less than 10, I plus plus. So we're going to have the same exact conditions here that we had before. Same exact conditions, because we're using the same pins. No surprise there, right? Now we're actually going to do our loopy bits. Digital write. Good Lord. I, high. Delay. Let's say delay 500. And actually, I'm going to do an interesting thing here. Digital write, I, low. And I'm not going to include a secondary delay, although you could do that, but I'm not going to. And you'll see how that affects the output when I copy and paste this into the code editor. Shabal, paste. And this should be our finished code. Notice how this is almost shorter than our single pin code. Like, there is much less work going on here from our end, much less repeated stuff. There you go. I'm going to pause it on that screen for a moment. Yeah, the code is up. Once you're fairly convinced, though, that you've copied everything correctly, go ahead and copy and paste it into your code editor, and then click Upload and Run and watch the light show. Pretty neato, right? So that is, well, how we can do the same thing, but with loops and more LEDs. And that pretty much sums up our hour, wraps up our hour right now. So let me go ahead, and I am going to unpause my screen real quick so I can show you guys what you might want it to look at. I'll pull it up in just a moment. I just want to show what the end result's supposed to look like. That's what you should be looking at. hopefully. I'm going to go back to the code. I am going to do the poll questions, but the code is going to be up in between the poll questions so that you can actually, you know what? Let me make this easier. I'm going to go ahead and put the poll or the code into the chat box. Bam, done. There's all the code. That is our entire code for this class today. Now I'm going to go ahead and do the poll questions, and then we'll leave it open for question and answer time like we always do. And then, interesting, delay not defined. Huh, that's curious. Copy paste your code and put it into the question box. In the meantime, though, we'll do the poll questions, and then we'll do question and answer.